Hello everyone. I welcome you all for online video tutorial by Department of Civil Engineering, Sai Vidya Institute of Technology. Myself, Professor Gautam, working as Assistant Professor in the Department of Civil Engineering. So in today's class, I am going to explain about how to calculate foundation settlement. Yes. Now, so when it is a foundation settlement, generally settlement happens in three stages or in three types of settlement. So first one is called as immediate settlement, and second one is called as consolidation settlement, and finally last one is called as secondary settlement. Okay, so there will be an three type of settlement, that is immediate settlement, consolidation settlement, and secondary settlement. Now let us see how to calculate these settlements for the practical condition or for the given problem. Okay, now let us take the first problem. Yes, let us see the first problem. Estimate the immediate settlement of footing 1.5 meter into 1.5 meter found at a depth of 1 meter in silty soil whose modulus of elasticity is 90 kilonewton per meter square. The footing transmits a unit pressure of 200 kilonewtons per meter square. Assume influence factor, that is I suffix s is equal to 0.82 and mu value is 0.35. Therefore, in the problem, you need to find out immediate settlement. The formula of immediate settlement is available here. Okay, the formula of immediate settlement is s suffix I is equal to q into b into 1 minus mu square divided by e suffix s into I suffix f, where q stands for intensity of the load, b stands for breadth of given footing, mu stands for Poisson ratio, e suffix s stands for Young's modulus, and I suffix f is influence factor. So in the problem, he has given Q value as 200 kilonewton per meter square. Then I suffix F influence factor is 0.82. Breadth of the footing is 1.5 meter since it is on square footing. So it is 1.5 meter. Then Young's modulus is 90 kilonewton per meter square. So therefore, all the values are available. You just substitute in this equation. You are going to get immediate settlement is how much? 2.39 meter. Okay, now let us move to the second problem. So in the second problem, a soft layer is 5 meter thick lace under a newly constructed building. The effective pressure due to overlaying strata is 300 kilonewton per meter square, and new construction increases the overburden pressure by 120 kilonewton per meter square if the liquid limit is 80% and the natural water content of the clay layer is 43%. Specific gravity is 2.7. Then dry density of the clay is 18 kilonewton per meter cube. Compute the settlement. Okay, here you need to compute consolidation settlement. Okay, now let us see what is the formula for consolidation settlement. So this is the formula you can see here. So this is the formula we are using for the consolidation settlement, that is S suffix C is equal to H into C suffix C divided by 1 plus E naught log of sigma naught plus delta sigma divided by sigma naught, where C suffix C indicates the compression index, E naught indicates initial void ratio, H is equal to thickness of clay layer, sigma naught is equal to initial overburden pressure at the middle of the clay layer, and delta sigma is equal to extra pressure due to new construction. Okay, now in the problem he said that H is equal to 5 meter, then liquid limit is 80%, then natural water content is 43%, specific gravity is 2.7, then he had given gamma d value as 18 kilonewton per meter cube. Now in this formula, one by one we need to calculate. First we will calculate this one, C suffix C, that is compression index. Compression index is given by this formula, that is 0.009 multiplied by liquid limit minus of 10. Liquid limit he has given in the problem as how much? 80. Okay, now if you substitute liquid limit value here in the compression index formula, you are going to get compression index as 0.63. Therefore, in this formula, C suffix C is available. Now let us see what is E naught. E naught can be calculated by, that is initial void ratio can be calculated by natural water content multiplied by specific gravity. Okay, natural water content is how much? 0.43 as given in the problem. 43% means 43 divided by 100, that is equal to 0.43, multiplied by specific gravity is how much? 2.7. Therefore void ratio is how much? 1.16. Therefore this is also available now. Okay, so E naught is also available. Next what you need to calculate is sigma naught. You need to calculate sigma naught. Formula is gamma saturated multiplied by H divided by 2. Okay, therefore in order to calculate sigma naught, initially we have to calculate gamma saturated, that is given by the formula gamma D multiplied by 1 plus W, where gamma D is 18 as given in the problem. W stands for natural water content, that is 43%, nothing but 0.43. So substitute all here, you are going to get gamma saturated value. Okay, so once you get the gamma saturated value, it is equal to 25.74. Then H by 2, in this formula H by 2. So H stands for 5, 5 by 2 is 2.5. To this, since gamma naught indicates initial overburden pressure, in the problem you have said that initial overburden pressure, you can see here, effective pressure due to overlaying strata is 300 kilonewton per meter square. You need to add this value for the gamma naught. Therefore 300 plus sigma saturated, gamma saturated, that is 25.74, multiplied by H by 2 is 2.5. Therefore sigma naught value is how much? 364.35 kilonewton per meter square. And delta sigma dash indicates overburden pressure. He said that, see, a new construction increases the overburden pressure to 120 kilonewton per meter square. So that you can substitute as delta sigma dash 120 kilonewton per meter square. So in this formula, this is also available, this is also available, this is also available, H is 5. So all the data is available. Substitute all the data and see what is your consolidation settlement. Therefore consolidation settlement is how much? 180 mm. Okay guys, for this session this is enough. We will meet in the next session with some more problems on foundation settlement. Thank you guys.